right? It says 7 times 8. Now, based on our options, right? Mental math, distributive property, and standard algorithm, Salome chose mental math. Salome thinks that mental math is the best way to solve our equation, 7 times 8. So let me see a silent thumbs up if you agree, and a silent thumbs down if you disagree. All right, cool. I don't see everyone's thumbs. Any 100%? All right, thank you, thank you. Awesome, awesome. All right, Salome, walk us through your process. Why did you pick mental math?
I picked mental math because mental math is really easy to do with this because it's just a number multiplied by another number and it goes in the ones place.
Correct, correct. All right, anyone want to build on that? Awesome. All right, let's take a look at Amari's work. Amari also chose mental math. Now, based on our vote from Salome's work, we know that mental math is probably the best solution for solving this problem, right? So let's move on to question 2.
Miss
All
Taylor,
right.
can we just stamp what we would call that kind of expression? So if we have just 7 times 8, we would just call that a basic fact. Yeah? Agree, disagree. We call that a basic fact. You can go ahead and write that down if you want. So basic facts are easy to do mentally.
I'll
Thanks.
write that one. Salome, Amari, I just wrote that on your packet.
Okay.
It's a basic fact. All right, let's move on to question 2, all right? So we have 85 times 100. So once again, we're looking at Salome's work. Salome thinks that mental math is the best way to solve. Now, I need you to vote yes, vote no, silent thumbs up, silent thumbs down. Do you agree? Do you disagree? Okay, all right. Wait, hold on. I don't see everyone's thumbs. Jake, I don't see your thumb. All right, Amari, why do you disagree? Why do you disagree?
I disagree because standard algorithm would be the best way to do this one.
Okay, why? That's okay. Gabe, I saw that you disagreed as well. Why did you disagree? Okay, but we want easy, right? Kamani, walk us through your process.
I agree with mental math. Because it's easy to work with the zeros. So you don't need to set up a whole standard algorithm or distributive property.
Perfect, perfect. We know that it's super easy to work with zeros. How did you use mental math to solve, Salome?
So basically what I did was I saw that it was 85 times 100. So first of all, I removed the zeros and I put 85 times 1, which is 85.
Correct.
And I just add the zeros back.
Perfect. So Salome did 85 times 1, which is what?
85.
85, and then she added in the zeros, giving us an answer of what?
85,100.
Correct. All right. I'll give you guys 10 more seconds for that to sink in, and then we will move on. We will move on. Give that back to you. You can actually take it.
Can somebody tell me why the 85 became greater? Like, I know we added zeros, but what was happening to the 80? What did happen to the 85? Go ahead, tell me.
We moved it 2 places down.
Yes, right? You shifted the what?
We shifted the 8 so we shifted the 8 to 8,000 and the 5 since the 5 was in the 10th place. If you move that down 2 times, it would be
Yeah. And why'd you say 2 times? Why'd you shift 2 times?
because if 80 is 80 itself, if you add 2 zeros to it, it'll
So somebody build on. We're shifting 2 times. Tell me about the 100. Yes.
We shifted 2 times because the zeros are taking the places of 85 and 8 and 5, which makes them switch because the zeros are taking their place.
Okay, what about the zeros? We call those, what do we call that?
Placeholders?
Placeholders. I'm looking for something else. Powers. What do you do each time you multiply by a 10?
I thought you were gonna say it.
Each time you multiply by 10, you do what? You shift it. So you shift for every power of
10.
10. And in 100?
Oh.
In 100, tell me, how many powers are there?
2.
2 powers of 10. So you shift 2 times. Very good. Thank you. Nice work.
So we shifted twice.
Yep.
Great job, you guys. Great job. All right, let's move on to our third equation, right? So we have 5 times 17. So Salome's answer, she put standard algorithm. Now, I need you to take a vote. Do you agree with Salome or do you disagree with Salome? Let me see those fingers. Go. Silent thumbs up or silent thumbs down? Kind of, you don't know? All right. All right, Isaiah, tell me why you agree with Salome. Okay, so you think it's easier? Looking for a quiet hand. Go ahead, Jake.
I kind of agree with Salome. I kind of chose mental math because I'm good with my 5s.
Okay.
Mhm.
But is that true for a lot of people? For most people?
No.
Okay. All right.
For most people, they would choose the algorithm.
Most people. Okay. All right. You right?
I chose mental math because you count my 5s on your fingers, they'll basically give you the answer.
I don't have
right away.
17 fingers.
I know,
Very
but you
true.
could.
Keep counting on like.
But is that the most effective way, though? Is that the most effective way? We're gonna ask one more person. Go ahead, Tabari. What are you thinking? Do you agree or do you disagree with Salome? Wait for that level 0.
I agree.
Hold on. Wait for that level 0. All right. Go ahead.
I agree.
You agree? Why?
I agree because not a lot of people are good with the 5s, and standard algorithm allows us to
It's okay. It's okay. So all right. Tell me why. One more. Tell me why.
So the reason I agree because so you can basically do 2. You can do process of elimination or you can do it. So it can be mental math because not everyone would go with their 5s and then one digit number times 2 digits, and it's too small to be distributed in process. So if you do standard algorithm, you're able to break it apart and that's easier.
Okay, so I disagree with Salome, and I'm going to tell you guys why, okay? So I need you to pay close attention. I need you to pay close attention. I need you to pay close attention. Thank you, sweetie. All right, everyone needs to track the board. Everyone's tracking the board. All right, so let's go back up to our problem. It says, blah, 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 including mental math, the distributive property with an area model. I know you guys are really great at area models. And then it says, or expression. So I'm gonna show you a little trick, right? It says area model or expression. Raise your hand if you know what they mean by or expression. Or expression. Parents? Okay? Kinda? Tabari, you wanna take a guess? Okay, so you kinda not really sure? All right, Urias, you wanna take a guess?
I'm not sure, but I think expression means like show it, like show your work, or like write it down, or like show it, like so you have proof to see it.
Yep, all right. So that's part of it, but let me show you. I need everyone tracking the board. Tracking the board. All right, so we have 5 times. Come on, you know this from summer school.
5.
Hang on one second. Let me set it up really quick, and then I'm gonna ask you. All right, so you know this from summer school. This is a different form of distributive property, and tell us what this means.
It means so since it's
Go to the board and like do the things.
That the smart girl.
You guys are all smart.
But I
Mhm.
think she's a.
yeah, done. Don't say nothing.
So you would distribute this,
Mm-hmm.
and then you also distribute it to a 7.
Can you explain that one more time?
So you'll distribute
Mm-hmm.
the 5 to the 10, which will cause 5 times 10,
Mm-hmm.
and then you would do the same thing by distributing the 5 to the 7, which will cause 5 times 7.
Can you tell us where the 10 plus 7 came from? Where'd that come from?
10 plus 7 is a breakdown of the 17.
Ah, breakdown of the 17.
Correct. All right, go ahead and have a seat. All right, so I just want to reiterate. You guys can clap. All right. Tracking the board in 3, 2, 1. All right, so I want to reiterate or repeat in my own words what Kamani said. So we're going to distribute the 5 and multiply by 10, right? So 5 times 10 is 50. We're going to use mental math. And then we have 5 times 7, which is 35.
I got it right.
And then you add them together. All right, I'm gonna give you 30 seconds, and then we'll all say it out loud. Okay? 30 seconds. Not yet.
So it's a mental math.
Mm-hmm.
We just got lucky with this one.
Don't say it, don't say it.
Don't say it. Don't say it. Don't say it. Terrence. All right, in 3, 2, 1.
35.
35. All right, so you see that? That was 2 steps. Super easy. So based on that, do you still think that standard algorithm is the best solution, or do you guys think that distributive property is a little bit easier? All right. All right.
Can we look at 7 times 8 and 5 times 17? Why is 7 times 8 a basic fact, but 5 times 17 is not a basic fact? Why? What do you think?
I think it is because I think.
Will you put your hair down first? Thank you.
5 times 10 is it 5 times 10? No.
The 5 times 17, why is that not a basic fact?
Because instead of a 0, there's a 7.
But 7 times 8 is a basic fact. What do you notice? What do you notice?
It's not
What I noticed is basically they're both ones.
In the basic fact? So what do you mean by that? You're saying they're both ones. What do you mean?
They're basically both in the ones place.
Yes.
But on 5 times 17, they have a 10.
Exactly. Exactly. So what makes a basic fact? Each factor is just how many digits?
1.
1. That's a basic fact. So if you have a 2-digit number, is mental math best for that?
No.
No. Okay. That's what makes it a basic fact. There's only 1 digit per factor.
Great job. All right. Let's move on to our last one on page 1. Okay. So.
Miss Taylor.
Level 0.
Miss Taylor. Let's pause there because we're ready to stamp the first fence post. The second one will be for the last problem.
There's no place to put
Put what?
the first fence.
To write the fence post? They can just write it anywhere on their paper.
Okay.
Yeah. Or even like they could flip it over and write it on the back.
I think this is fine.
So,
So our first fence post is mathematicians use different strategies to multiply based on the factors. Do you agree or do you disagree?
I agree.
Agree? Agree? Okay. So let's stamp that. Mathematicians use different base
So-
paper looks like the board.
So our big question there is like, how do we decide which strategy to use?
I can't see.
I know, I'm fixing it. We'll get to that one second.
What do we use when we're deciding which strategy to use? What do we look at?
You're gonna write it where I've written it at the bottom, because we're gonna put, our key point in the box. Good question. Alright, 30 seconds. Get this down. Once again, your paper looks like the board. Good job, Jake. Amani. Good job, Kenneth. Good job, Urias. Thank you for that silent hand signal. Good job.
That's not her work. That's the one that's right.
Oh yeah, this is remember, we're still looking at Salome. All right, track the board in 3, 2, 1. Thank you. All right, let's move on to our third and final problem on page 1. So we have 422 times 329. Now Salome thinks that using the distributive property and an area model is the most efficient way to solve. Now, silent thumbs up or silent thumbs down. Do you agree or disagree? Let's see those fingers. Terrence and Layla. Oh. No, I need you up too. All right, fingers down. All right, why do you think that distributive property is the most efficient method to solve? Go ahead, Amari.
I think it's the most.
You think it's the easiest way?
I think it's the easiest way because my brain just.
It's okay. Anybody else want to give it a try? Go ahead, Salome.
I thought that distributive property was the easiest way to solve because the numbers.
I see you.
Because the numbers have the same what's it called?
The same.
They both have the same number of place values. So to me, when a number has the same number of place values, it's just easier to solve.
Okay. I think I understand what you're saying. You're saying that they both. So it's 3 digits. Both of them are 3 digits. Is that what you're saying? Okay. Come on.
I think on this problem.
Hang on 1 second. Wait for that level 0. Alright, go ahead.
On this problem, it's easiest to use distributive property since we have bigger numbers. Because if we did standard algorithm, it would take too long. So distributive property is the easiest way.
Okay. One more person before I give my explanation. Urias, what are you thinking?
I think that distributive property is the easiest, personally for me, because I usually use distributive property on almost all of my math work, especially big numbers. I think it's more efficient for big numbers, and you could actually see what you're multiplying, and you could see the zeros and stuff like that. And I just think it's easier because I can see all the numbers and stuff, and it makes it easier to do math.
How many partial products would you have to add up if you're doing the distributive property? 9. That's a lot of numbers to have to add up.
So my question is, or before I get to that, I'm going to tell you, I think that standard algorithm is the easiest and most efficient way to solve. And I'm going to tell you, I don't know if we went over this yesterday or the day before, but estimation.
Oh yeah, estimation.
Estimation, right?
Because
It's another way of multiplying, and it gives you an idea of like the ballpark range of where the answer should be, right? So let's say,
Do you have an example of the standard algorithm to look at?
What's the estimation is that?
it will be. It will be.
Wait,
Grab a piece of paper.
it's not already filled out on that?
Oh,
Can we just look at it?
yeah.
So distributed property, you're gonna have 9 numbers to have to add up. What about standard algorithm? It looks like how many rows are there to add up? Just 3. So 9 numbers to add or 3 rows of numbers to add?
3 rows of numbers.
Which one is easier? Mm-hmm.
All right, so based on that, which method is easier to use
Bless
when
you.
solving bigger numbers? Bless you.
Thank you.
Is it distributive property or is it standard algorithm?
Standard algorithm.
Standard algorithm. So let's talk about our key point here. So it's already written down. It says the standard algorithm is the most efficient way to multiply bigger numbers. Who can explain in their own words why it's easier to use standard algorithm versus distributive property? Write this down first and then we'll come back to that. Get it down first and then we'll come back. 20 seconds. Why? It's okay, we're moving on to the second page. It's all good. I think it's art.
That's the second page.
No.
No. Alright, 10 seconds. Ooh, sorry.
You catch something.
Alright, slant in 5, 4, 3, 2, 1, and 0. Alright, great job, 5th grade.
Nice.
Yes, Amari?
Can I say my own one?
Yes,
Mhm.
absolutely, go for it.
Standard algorithm is better than doing distributive property because for distributive property you have to do way more adding, and with standard algorithm you only have to add 3 numbers.
Can you repeat that one more time, sweetie?
Louder too. Well said.
Standard algorithm is better than using distributive property because standard algorithm you only have to add up 3 numbers together, and for distributive property you have to add 9 numbers together.
Perfect, perfect. Love that. I see a lot of people agreeing with you, Amari. All right, great job. I need you to turn